I like to start things just with an entertaining little story about something that might be familiar with all of you guys. So this is a slightly exaggerated story of a dev, or life of a dev. So the lead developer says basically, hey boss, we've got this application, it's at 1.0, the client loves it, let's just send it out, let's put it in the world, let's get it working. The manager says, let me check with everyone in the company, because that's how it works, and then I'll get back to you and we'll deploy it if it's ready. So then all hands meeting the next day, the CTO says this huge speech, this very busy, buzzwordy speech about how we're going to change the world with it, and he says, let's launch it. And the lead developer goes to the keyboard, types his commands, and because we're hooked into something like Heroku, we can push to GitHub and it'll automatically deploy. So we do that. Slackbot cheers, everything is good. So 6 months later, we get into work that morning, and we learned that from New York Times that there's been a massive leak of credit card info, all kinds of information, and passwords that were poorly hashed or not hashed at all. Slackbot has also been taken over, and we have to send bitcoins to get our bot back, and of course, it's also a weird name. So people that went to the Slackbot talks, those were awesome. Just beware, your Slackbot is not off limits to hackers. And what happens? We all freak out. The world's ending. People are losing their money. And then you just feel like this. So we're going to go through some baby steps and teach you. First, we're going to talk about how security works, why it matters, how to think like an attacker, and then we're going to get into some really in-depth stuff in JavaScript and what you can build into your applications to make them work better. Work better in the sense that they'll be secure. I'm doing really good in time, so I'll maybe slow down a bit. So the first step is to understand the problem. This is a picture from just the other day, updated from informationisbeautiful.net. Of the world's biggest data breaches. You can see some of these on here, Yahoo that was on here. I mean, LinkedIn is somewhere, and it's like minuscule here. eBay, Home Depot, when you heard about the credit card information. Friend Finder is more recent, MySpace. All kinds of stuff here. It's really a problem, and these breaches cost millions of dollars. And even more on top of that, incident response, a survey was done by IBM, and this kind of concerns the stuff I do at Oak Ridge. I'm not just making up stats. Incident response costs $4 million per breach on average among the 380 global companies they surveyed. So security doesn't exactly provide money directly. It's not like if I put some nice headers in my application that protect against bad scripts. That doesn't give your company the money that it wants right then. What it does is down the road, it saves you potentially millions of dollars in damaged reputation, mad customers, incident response, advanced solutions that you have had to deploy, people to hire. It saves you money in the long run. And that's why a lot of people put it off to the side because they don't see the direct value in it at the time. So we have a lot of vulnerabilities. Like I said, it's hard. Heartbleed, 2014, it was living in the OpenSSL code base from 2011, and it was discovered in 2014. For 3 years, anyone that has a server in here that was deployed on any hosting service, AWS, DigitalOcean, Bluehost, who knows, you could just arbitrarily read data off those servers. So I could send one command to your server and get all of the keys off your server, your private keys, all of that. And who knows how much that was exploited. I'm sure government agencies around the world are exploiting it because they probably knew about it, hackers, whatever. They just found it in 2014, they made all these pretty logos, and we're just like, oh, cool, we don't have to deal with that again. But turned out others. Shell shock was a bash bug. Poodle was a SSL degradation, SSL to HTTPS. We could basically say you are running an HTTPS site, a secure site, and we could degrade you to some old version of SSL that wasn't as effective. That was the Ghost vulnerability, which was a vulnerability in glibc, which is the fundamental library on Linux computers that does everything from the open command and syscall. So a node, if you open a file, it's going to call down into this function. It's the foundation of Linux. There's a vulnerability that allowed anyone to remotely take over your computer without any credentials on it. That was a big one. You may never hear about these things if you don't follow the appropriate channels, but if you follow the right people on Twitter or you subscribe to Microsoft's vulnerability feed, stuff like that, you'll get it right away. Stage fright, that was amazing. I thought this was hilarious. You could send a message to someone's Android phone, and this was recent, I think in the last year, and you could take over their computer or their phone and root their phone remotely. And so, I mean, I could just get in your phone, do some kind of message sending, and we'll go into the details and just have your phone. It's mine at that point. And that's where we get things like the Dyn DNS, and Twitter and GitHub were down the other day. That was millions of cable boxes that had network connections that destroy Twitter and GitHub's DNS infrastructure, or the infrastructure they use. So it's really important that the people here that do IoT, web, whatever, everything we put an IP address on, everything we connect to the internet, has the power to take down the world's biggest sites that people use for a lot of important things. I mean, yes, Twitter, sure, it can go down, but GitHub, people deploy code off GitHub. Healthcare companies deploy code off GitHub. It's really a frightening thing that we have all of this. And of course, we have Flash, and Flash, and Flash, and Flash. And eventually, we have WordPress, and WordPress, and WordPress. They're not bad things. They just have very big code bases, and they're very vulnerable to this stuff. The developers of those platforms aren't bad people. They just have a lot to manage, and that's why it's important that we think about this stuff. So, more WordPress, more WordPress. So it's obviously a hard problem. It's a really, really hard problem. Vulnerabilities can be everywhere. So this is a not very beautiful thing I made in draw.io, which is Google's old drawing thing, that has the layers of the TCP/IP model and the OSI model, which are the two networking stacks. The models represent those. And you can see all the protocols and services within each layer. I've highlighted in blue some of the more important ones that you deal with more often. So who in here has used Meteor before? Anybody? Meteor, it's a pretty cool framework. DDP is the way they communicate data. That's in here. WebSockets, who's used WebSockets? And you've probably used them if you don't even think you have, because it's like underneath everything. ASCII, believe it or not, IRC, SSL, SSH, all of these protocols are composed of millions of lines of code, and all of those have vulnerabilities. And because we talk over things like HTTP, we're dealing with all the properties that HTTP has. So it's important to use things like SSL. It's important to do things like certificate pinning, where we have to make sure that people can't reverse engineer our apps on our phones. So that's the thing. If you have an SSL certificate on your iOS or Android app, I can reverse engineer that certificate and basically bypass the fact that it's encrypted if you're not doing certificate pinning, which is a way to disallow that. I won't go into that either. Those are all important things. I've worked on consultant gigs and stuff where I'm like, hey guys, you should be doing this pinning. There's not a direct vulnerability. But it was really easy for me to go in and just see what you're talking to back to your server. And they're like, no, we don't think it's a big deal right now. I was like, okay, you can't fight them. I mean, you can try a little bit, but then they'll just fire you. But there is hope, and I don't know if I have sound, but Star Wars, cue epic Star Wars music. Who's going to see Rogue One this December? Who saw the last Star Wars movie this December? Did you guys like it? Was it good? Yeah, Rey was definitely my favorite character of all the movies. I mean, I obviously was 10 years not alive when the first few came out. Maybe longer, but I watched all of them. I was a big fan, and she was really cool. So yeah, that was good. That was a good movie. I hope you guys see the next one. So it's important that first we understand that there's a problem, and second we understand that there's a right way to do this kind of stuff. There's a right way to approach security that will help us build better applications and not succumb to Heartbleed and all those other terrible things. So first way that's wrong is security through obscurity. That's basically when you keep your system safe because attackers don't know what it is, how it works, they know nothing about it. But I mean, they don't. They're always going to know something about it. So that's not the right way for that to work. When you see someone say, we have unbreakable cryptography, unbreakable security, that is absolute BS. They do not. There's no such thing as perfect security. If someone says to buy my product for $50 million, that we will secure your websites with the best encryption known to man, if they don't publish their source code, then don't buy them. That's ridiculous. And if you ask any cryptographer that's way smarter than me about mathematical properties in crypto, they'll always tell you there's a way to get around it if you spend long enough looking at it. I mean, yes, maybe one day when quantum computers come out, we'll find a better way, but who knows? That day is not right now. So I don't know if this is actually a specific one, but I came up with it. Someone else probably came up with it, but Basically, you just completely ignore that security is a problem, and you just go about your jolly day and forget about it. So yeah, that's also not good. It really sucks. I'm telling you, it really sucks to think about security sometimes because we just want to build better functionality, build features, build a better UI, all of that kind of stuff. But it will save you a lot, and I'll show you. I mean, I think I've already showed you that we have vulnerabilities and they exist. I'm going with the assumption that you guys know that people get hacked all the time and that this is important. So I'm here to tell you about how you can actually do it pretty easily. So I think this is my opinion, and the opinion of most of the community is doing it this way. So security by design is when you design it from the ground up as you build a whole application from the phase of prototyping at a lesser amount, but from the phase of prototyping to actually production deploying to design it to be secure. So that means thinking about security in the sense, okay, when it actually gets deployed to production, I need to have HTTPS, I need to not show identifying information, so not have these headers that tell you that your backend's in PHP or Node or Express or whatever, which do exist and are often on by default. Keeping things like that in mind. Acknowledging that vulnerabilities can occur in code. We all know that happens. Some of us here may have been affected. Who here has had their, I don't know if you want to disclose this, but if you want to, who here has had a company that's been affected by a breach before? Yeah, so it's a non-negligible amount of people. And how many people or how many people here dealt with the QA team coming and the operations team saying, like, fix this or fix that? Anybody? So nobody had to work with the dev team or the security team to, like, fix the vulnerabilities after they discovered them? A little bit? Okay. Yeah, so that's one thing, is that when things are discovered, there's this constant dynamic between the dev team and often the security team. We're like, hey, I found this problem, go fix it. And if they do, that's great. If they don't, then you just deal with it. And that was a big thing we dealt with at Cisco, is that the company has 172,000 employees, and the 9 of the 12 root routers on the internet, the switches, are on Cisco hardware. So over, what is that, 3/4 of the internet runs on Cisco hardware. And we were responsible for breaking into our own products before the bad guys did. And so if we found something, we disclosed it through the internal system, and those teams would fix it. We would hope they fixed it. And Cisco is great. It had a very good security culture, so that was stressed. But if you're in a smaller company and the people above you, or below you, whatever, don't think that security is important, but you're telling them to fix things, then that's obviously an issue, and we'll get into a little bit about that later. So again, maintaining and prioritizing a security team, even if it's just one person, is a good thing to do. And thinking about how attackers will try to hurt you. So that's great. Let's make sure and focus on this. So the next thing is understanding the enemy and yourself. I had a really not so insightful quote by Sun Tzu here. I figured I'd take it out. But basically, you've got these two opposing parties, and you think of like black hat and white hat hackers. So this is from an old comic. It comes up all the time when you look at black hat stuff. It's probably from something you guys know more. Yeah, I mean, about the extent to which cartoons I watched was like Tom and Jerry, and even that was kind of like before my time, and so I'm not pretty young. So what are hats? What are black hats and white hats? We have black hats, white hats, gray hats. What's all that mean? So they're used to classify hackers by their motivations, purpose, compensation, whatever. And again, the term hacker is like really it's used in all different kinds of ways. When I refer to it as security. When I run the hackathon, I refer to it as students or people that want to come and build stuff that wasn't there before. It can be anything. But in this case, we're talking about people who do some kind of security. Okay. So motivation, who cares? It's really helpful to understand the motivation that attackers have, that also defenders have when they go about building systems and attackers going to attack them. It could be money, power, destruction. For the bad guys, often for the good guys, it's morality, responsibility, and protection of the users that they're going to try and save and not lose their information. Some of these things, there's a gray area in between. Some people are different. So white hats are the people you think of when you think of NCIS, because you can type on a keyboard. Two people can type on a keyboard at the same time. We learned that from this. So this is what I do when I go to Oak Ridge. This is exactly what I do. White hat hackers are security researchers, practice responsible disclosure, which is when you disclose it without actually publicly disclosing it. First, you give it to the company. Bug bounties. Facebook gave out like $14 million last year. It's either 4 or 14, a lot in bug bounties. They spread security awareness. Go back and tell your companies, hey, security is a problem. Let's think about it more. Let's at least do a check in our build tool or our test that tests these properties. And they also maintain active Twitter accounts. Please, if you ever want to follow security people, the good guys are often always on Twitter. The bad guys are on there too, but the good guys, the anonymous hackers, that whole group, they often like to screw around and just completely DOS their accounts and do stuff like that. But the good guys do have Twitter accounts, so follow them. Don't follow me. I don't. I'm now stuck in this place where I like JavaScript and I like security. And now if I tweet anything about JavaScript, the security people are going to unfollow me. But if I tweet anything about security, the JavaScript people will unfollow me. So I'm stuck in this weird place. But there are way better people. Black Hats. This is probably one of my favorite movies of all time. It's Hackers from 1995. So this is where hackers in the back end, the bad guys, they are hacking the Gibson, which is in this movie. And obviously there are these like white, old, like neck-beardy dudes. Like, no. Like Black Hat hackers can be anybody. Who knows? Like it can be a cat. I don't know. It can be a dog. It can be your mom. So just be aware that Black Hat hackers do this. If you ever see a room with a bunch of neon lights, it's probably bad guys. So that's from 1995. So Black Hat's motivations are usually money, which like the LinkedIn data breach, they stole a lot of the credentials. Power, North Korea and Sony, you can arguably say that was for power. Destruction, the Ukrainian power grid was just knocked out a few months ago. I mean, that's a bad thing. The US electric grid is in a terrible state. We spend billions on research in the country working on that, the national labs in my university and others. Revenge, hacktivists, the funny people that like to screw around with stuff just because they're doing it for the greater good. That depends, they can be good or bad. So what's a vulnerability? It's when you make an application do something that it's not supposed to do. And to find them, you have to understand your application. And that's great for us developers. Those of us that can write code, you're already light years ahead of security operations people that have never written code before. If you ever go and interview for a security job, a lot of times they'll ask you, hey, do you know how to write code? And if you do, that's good, because when you think about it, if you are pen testing a site, and pen testing is penetration testing, when you try and go hack into some website or product and then disclose vulnerabilities, if you know that this form field, this password login field, how it's implemented or can think about how it's implemented, then you know what to target. So you know it might not really be a great idea to go into the browser inspector and change the background color of the page of CSS to blue, because that's not going to do anything. I mean, why would that do anything? But you might start trying to fuzz or inject a lot of data into the password field and keep clicking submit until you see if you can find something. So it's good to be wary of how things are implemented. So it's good to know the application. So thinking about the functionality, the intended behavior. So it's important to think intended functionality and intended behavior. What does the application use as input? This is the biggest one. And what does the application produce as output? So thinking of these things are the most important things to think about when you're looking at an application to see if it has some sort of vulnerability. And I will have all these slides online later, so no worries. Here's an example, Wikipedia versus CNN. Suppose that you find that authenticated regular users can edit page content. So is it a vulnerability? If you think it's a vulnerability on Wikipedia, raise your hand. What about CNN? Anybody? Yes. I think it'd be bad if we found that, I'm not going to get political, if some CNN posted an article about cats and someone edited that to say that the cats are now president and they're taking over the country, we'd probably say that's a vulnerability. Wikipedia, obviously, if you're authenticated, you can go and change content because that's how Wikipedia works. So it's good to think of things in the context of how they work. Attacking is a process. So this step one is almost always reconnaissance, investigating it, investigating the headers that are sent, the code itself. On the client, that's looking at the state that's maintained, the local storage, your cookies, all of those things, the flags in the cookies, stuff like that. Two is develop a vulnerability hypothesis, and this will be repeated over and over, thinking that, hey, I've got this form field, maybe I can inject it with something, maybe I can do something with it. Three is to test that. 4 is to develop an exploit, assuming you find that your test worked, kind of formalize it and distribute the code to the company and say, hey, I found this problem with this code base, or your boss, whatever. And then step 5 is profit, get swag, or protect the world. And your mileage may vary on that. So bug bounties often do like swag or money or whatever. Google's cap is like 40 grand for Android remote code execution vulnerabilities. So if you find a way to hack into their Android phone without being authenticated, then and run code on it, then they'll give you up to 40K. And taxing does apply still. Somebody, United.com just opened up a bug bounty program, and a Georgia Tech student found 20 low to mid-level vulnerabilities, not very big ones, and he got about 300K worth of airline miles. So it was like 100 million miles or 10 million or something ridiculous. And the government just came to him the other day and was like, hey, you got to pay taxes on that now. So woo! So a student has to come up with taxes for 300K of stuff. So hopefully they can just take some miles. But yeah, you can get cool stuff by doing this. So you can see this is very much it's almost like the scientific process of thinking about an experiment, how do I test it, and then how do I actually formalize it, and then how do I go and give it to the people. This last step is more of the disclosing of the thing or using it to take over the world or anything like that. Okay. So injection vectors, it's important to understand all the input to the application. Like I said, form fields are just one, but we have a lot. Query parameters, URL path, post parameters, cookies, headers, file uploads, functionality, emails, form fields, WebSockets, local browser storage. There is so much here. Anything where you can get input into the application and back to the backend or the client, depending on how much logic you expose in the client, that's a potential attack vector. You're going to be thinking about these things when you design your app, because you want to think, how do I protect this? How do I validate the input? How do I do rate limiting, things like that? So you have to understand data flow too. So it's important to understand if data goes from X to Y, what is it going through and how is it getting there? And what are the things it's affecting along the way? I mean, how does the output of the page flow through the program? So if you make a new Facebook post, and the post on the newsfeed displays, but also on your timeline makes something new, is there a vulnerability where by posting in the newsfeed, something won't show up, but then when someone likes it and it shows up on their feed, it runs some malicious script that you hid in the post, and then they are now taken over from their account, which does happen, and it has happened before at Facebook and other places. So now I'll actually talk about JavaScript and what it means to write secure code in JavaScript, and the modules you might want to look into, the process, that kind of stuff. So this is my favorite GIF. I don't know if it's real. Does anybody know if it's real? Raise your hand if you think it's real. I mean, it's there's a really, I don't know. That's great. I love that. Okay, so I'm going to have a little legend of how I'm showing stuff. So I'll have a yellow box and link to software. Software is now a top-level domain. Whoever came up with the idea that .coffee and .software and all this other crap should be top-level domains, that is awful. Never do that. That's why? I don't know. When I got my first domain, I couldn't find a jaredsmith.com because it turns out jaredsmith.com is also someone that does development and also does security. So I was like, great, that was the best name to have. So I did jared-smith-smith.net because my friend told me that .net was the best domain name. I was like, okay, cool, let's do that. Hopefully he watches this. So yeah, that's kind of what I'll show. So the first one really to look at is command injection. So it's when untrusted data is sent to an interpreter of some kind, whether it be SQL, an eval statement, JavaScript, it doesn't matter, something that interprets input as part of a command or query. So it's the injection of malicious code into programmer logic, like I said, through SQL, NoSQL evals, OS instructions, like an open file in the system. If you can get data across SSH and have it run and open and do some weird stuff, that's also that. LDAP has a lot of injection. When you do security for a while, you'll realize that Windows is just a treasure trove of vulnerabilities. It's so much fun to pen test. It's a blast. But for Mac is not really it used to be the thing that you would have if you didn't want to get a virus. But now that happens all the time. So I don't think anything is safe anymore. And we also have refrigerators DOSing people's Twitter accounts and sites. So nothing. Go to the LoCent talk after this. They're giving a talk on hardware workshop, and they do IoT, and I talked to one of their guys about this stuff, and they think security is important, which I think is great, so that's good for them. So command injection, so how to combat that? You want to validate all your user input on the server side, not just the client side. It's great to do it in the client, but also you have to do it in the server before you throw it to any interpreter. Don't use eval. I know who uses eval, but set timeout uses eval, set interval, function, new function, that uses eval underneath. Everything that goes into these needs to be sanitized. Honestly, everything you do needs to be sanitized. And then I found this really cool library called Express Validator. It's got a significant amount of stars on GitHub. Everything I post has it's been updated within the last year at least, most of them in the last few days, and with some amount of traction. Obviously, you can validate yourself too, but this kind of adds some nice stuff for it. So cross-site scripting, this one is a blast. This one, I really love cross-site scripting. So you can basically run malicious JavaScript in a victim's browser in the targeted application. So successful XSS can steal user information, cookies, session IDs, redirect them to malicious websites, download malware, act on the user's behalf. It goes on and on and on. So Mark Zuckerberg, a few years ago, he was hacked by this guy when he told Facebook that there was a XSS vulnerability, and they didn't respond, they didn't handle it very well. So it was like, great, the best idea, the best thing I could possibly do here when I found a vulnerability that I can get thousands of dollars from is to go to the CEO of the company and take over his account. That's the best idea. So he did that, and I don't know what they did to him, but they definitely did not give him the money. So that was XSS. There's plenty of other examples. It's basically, with XSS, you are able to post, think of it like a snippet field. If there's a site that takes code snippets, imagine if that code snippet field would let you put a script tag in it. And then when that gets displayed on a new page, that script tag will load, the user won't see it, and imagine that script field is not, instead of alert, you've been hacked, because it's the worst thing to do, it's instead XML HTTP request, because that's in everything, document.cookie to jaredsmith.com/command and control server. And now I have your cookie, I can go to my browser, use a nifty Chrome extension, log in as you, and start tweeting bad things about yourself. So that's as easy as it is, and it's the only thing that will prevent that right now is sanitizing your input. There are efforts to do automatic contextual sanitization. That was my senior design project. We essentially were able to rewrite parts of the PHP interpreter using an extension and modify all input as it comes into the application on the fly with less than 2% overhead and sanitize any input coming from the user based on the context. It works with PHP 5 and 7, but obviously no one's going to use it because they don't want to install an extension. It's really hard. It really sucks. So they're not going to do that. But there's other things. Angular has a built-in contextual escaping. Django does it by default. So things are starting to pick up on that. So again, validate and sanitize all user input. And code output. It's really like if you have a snippet field and you can put HTML there and it's not supposed to be there, and then the next page shows HTML, you can get rid of that just by encoding those HTML tags. If you at least just escape the script less than greater than, you'll be much better. Set appropriate headers. I'll show you essentially in a second that'll set things that browsers now recognize that prevent XSS more automatically. Chrome also has XSS Auditor, which filters out some amount of XSS. And I'm not really going in depth into a lot of this. If you do go to some of the resources at the end and look into more of this web security stuff, there's lots of different classes of XSS and things like that. So validation, again, you can use that library. And setting appropriate headers, this helmet library is great. I saw someone with a React library that was helmet as well. This is different. This lets you set all kinds of headers in your things like secure cookies and all kinds of stuff like that. Please use it. It's simple. It's an Express app. It's like 5 lines. Okay, I'm gonna have to go a little faster. Cross-site request forgery. This is kind of complicated, but it's an extension of XSS where you can basically frame on top of someone's browser. Essentially what you're doing is making them click on a site underneath your page that they already have loaded in the background. So if you have, Jared Smith or jaredmichaelsmith.com/blog, and they're on my blog, I can put a window of Facebook behind it that's invisible, and if they are authenticated to Facebook already, and Facebook has a cross-site scripting vulnerability, then I can make them click on post or send me money. A bank is a good example of this. I can put their bank behind that and make them send money to me when they only think they're on my blog. And that happens. That happens all the time. It's really not an uncommon thing. All of these things happen a lot. And these are things that can be prevented by validating input, stuff like that. Attackers usually target state-changing requests. For a nuance of the way it works, you have to target requests that you can predict. If you can randomize requests in a way that they can't duplicate it, then this can't happen. So the way to deal with that is just to include a random unpredictable token request, add tokens to requests which mutate state. And this CSRF library is super popular and does it for you in Express. You will be vulnerable to CSRF if you have an XSS vulnerability if you don't use CSRF. All it does is add a nonce, which is a random token, to your request, no overhead, and it just validates it. I mean, I say no overhead, it's completely negligible, and that will prevent CSRF, because then you can't essentially make them send a request on your behalf, because they can't predict what that request will be. Session management, please, 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 please don't implement your own authentication mechanism. People that built OAuth and all of those things did it and spent years doing it because, frankly, they're a lot smarter than me and probably smarter than most of us. They know what they're doing. They've dealt with authentication for a long time. So again, developers often do implement their own authentication. I hope you guys don't, but just don't do that. So session management is hard. I mean, it's cookies being stolen, stuff like that. Don't expose the session token URL. A few years ago, or actually a long time ago, there's a guy named, I can't remember his name. He's in a bunch of documentaries. He basically found a vulnerability where AT&T had the user tokens that identified them as the URL, so /URL, and they were iterable. So it was like /1, /2, /3, /4, and you could get to their page with their credit card info right there by doing that. And he made a big deal about it. He told the whole world, but without telling AT&T, or maybe he told them first, whatever. He went to jail. I can't remember his name. He's actually a pretty terrible person. He's not very nice. Session tokens should time out. Make them time out. Don't have session tokens live for years. It's a terrible idea. Recreate them after a successful login. This is a standard practice. Always recreate them after you log in. And use HTTPS for sending tokens and appropriate permissions. And also use OAuth 2.0 or SAML or some appropriate authentication mechanism. There are libraries in JavaScript that will do this. Permissions, you can do that. And Passport, that's what I was going to get to. That's a very simple authentication library that does OAuth and all of that. It's very, very popular, and Express uses it. A bunch of you might already use it. And this permissions library makes setting permissions easy without having to write your own logic. Password management, they're often handled incorrectly. You can't just leave your passwords in plain text in your database, obviously. You obviously can't, or you can't encrypt them either, because if someone steals the key, they can just decrypt it. So why are you encrypting it? That's the point. You can't just encrypt it. You have to hash it. But if you hash it with algorithms that are 15 years old, like SHA-1, then I can crack it with my laptop in like less than a second. So you need to use good hashes. You also need to use salts, which are essentially random tokens appended to the end that add additional protection. So an example is the 2012 LinkedIn breach. Passwords are hashed but failed to use a salt. So when they fail to use a salt, you can look up things called rainbow tables, which is a mapping of hashes to passwords, or it's basically that. And then you can crack the passwords more quicker. And there's tools that already do this stuff. If you look up John the Ripper or Hashcat, they use GPUs and do it in no time. So use bcrypt. Bcrypt is the standard hashing algorithm. It's developed and approved by cryptographers. It's open source. Enforce strong passwords too. And also, please, we're 2016. Let people use two-factor auth. I mean, like, why would we not be doing that? If you can, prefer the TFTP, which are the one-time passwords, or U2F, which is the great new FIDO YubiKeys. It's these things right here. If you see those, GitHub lets you use it. Google lets you use it. Use Google Authenticator for the one-time passwords, or Authy. If you have to, you can also use SMS. But the thing is, these days, AT&T and Verizon, all those companies do a terrible job of validating and signing your text. So someone can spoof your text and log into your Twitter account with a phone that's not yours, but can make AT&T or Twitter think it's your phone. That's the thing. It does happen. So hashing passwords with bcrypt, that's the Node bcrypt implementation. It's other places as well. Two-factor auth. I found this library that's kind of old. I'm really surprised that two-factor auth isn't really well maintained right now. Maybe people just implement it themselves. But yeah, you can use the SDKs. Cookies, I'll go a little bit faster. You have to set cookies using the following flags. Secure and HTTP only, let them be only accessed by HTTPS. In JavaScript, HTTP only means that you can't do that XML HTTP request document.cookie, because then it can't be accessed. There's other ways to actually do it properly. Scoping is when you can do things that only let the cookie be accessed by your domain, your own website. So that means that CSRF from another site can't happen. So there's some permissions right there. Cookie session is a wrapper on cookies. Those are pretty big packages. And then KeyGrip is a cool library for signing and verifying that cookies are the same and do still exist. Strict mode, I mean, you may hate strict mode, but it's really great. Please use it. Prevents silent errors from happening. Helps the JavaScript engine also perform optimizations. You don't have to use it. It doesn't prevent all types of vulnerabilities. It really doesn't prevent anything explicitly security, but it helps errors not fail silently. Information disclosure, that can be a bad thing as well when you accidentally show the users or people using your application too much information about it. So stuff like the X powered by Express header, you want to disable those things. Often they're disabled by default, but if they are enabled, you should disable them. Sensitive data exposure, please don't expose people's data. Don't let your whole entire state's voter registration database just be sitting on the public internet. Georgia did that, and everyone in the entire state lost all of their information, social security cards and everything. That was like last year. Don't break users' trust. Use SSL HTTPS. It's 2016. We should see a green shield in your browser. If we don't, please do that. Who is not using HTTPS in their production app? I mean, okay, I know you wouldn't raise your hand, but I know everyone would. Still, I mean, we have to talk more if you are. Encrypt data at rest and transit, disable caching in forums. Often that stuff gets stored in local storage, which can be accessed by XSS. Let's encrypt free SSL certificates. Why are we not doing it? They're free and they're in every single browser you already use. Some useful tools, there's something called Retired.js that will scan your packages for vulnerabilities automatically. You can do it in your npm build scripts. Node security platform is super great. It was updated like yesterday, or one of these was. This is recent. It's still being used. It just adds to npm a CLI, and it'll do live automated security tests. Automated tests are better than no tests. The best thing is doing security audits of your platform. Docker is great. Shrink wrap is good. So takeaways. This is the last thing I'm going to talk about. Takeaways. Acknowledge that security is worth spending time on. You can see that this is a problem. People deal with this. We don't want this to happen. I don't want you guys to lose your information, and I don't want you to come back and tell your boss that I taught you something, you didn't implement it, and you come and blame me and sue me for what I did and didn't tell you. Understand application security at a high level. I gave you some tools to do that. Just if you want to learn more, read about it. I'll have resources at the end of this that you can get from the slides later. Have the mindset of an attacker when building and testing your systems. Think about not just how it's developed, how you're developing it, but how someone would attack it. That helps you enforce better properties. And then use security best practices. That's all the thing I told you. There's a lot more there. There's a lot more security stuff, but I gave you some of the highest, the biggest ones. And finally, go back to your companies and tell them that security is important. So again, if you spend more money in coffee than IT security, you will be hacked. You deserve to be hacked. So that's this great clip. Like that. So, I mean, you will be hacked. Thank you. If you have questions, come see me afterwards. You can reach me in all those places. Thank you.